more of the same, that 1, 0, all the ones and the zeros, but on our 3 equations, 3 variables. So, incredibly wordy at the beginning. We just have to go over a few things. We are going to be putting our matrices in what we call reduced row echelon form. That is the diagonal ones and then the zeros. So that's what you did on those 2 equations, 2 variables. That's what we're working at. So that's just what all this is telling you. First non-zero number, this is called the leading one. So the diagonal ones, leading one, whatever. All the other numbers above and below it should be zeros. Every number, of course, if you have a row of zeros, like this guy on the side here, if you have a row of zeros, that's going to end up at the bottom. And remember, a row of zeros is your infinitely many. 0x, 0y, 0z equals 0, 0 equals 0, infinitely many. So this is diagonal ones, zeros above and below. That's what we're looking for. Okay? So this is just kind of giving you, I might get it dramatic on your notes here, giving you kind of the process of the order, how to work on it. So just like the 2 equations, 2 variables, I always make sure this guy is a 1. Always start top left with a 1, and then I turn the other 2 numbers into zeros. Just like I did on the 2 equations, 2 variables. And then I always work on column at a time. I go to the next one, and I try to turn the numbers above and below into 0. Just going to put a 0 in that one for dramatic purposes. So it's the order you're working in. So, third column, I get my 1. So you have the diagonal ones, and then I turn the numbers above and below it into zeros. So you're always working a column at a time. So first column, second column, third column. You're going to try to get the 1 in each column first, and then turn the remaining numbers into zeros. That is your reduced row echelon form. That's a mouthful. And remember, the numbers at the end are what your answers are. Because this top equation would be 1x, 0y, 0z equals the last number. 0x, 1y, 0z equals the last number. So this is going to be z equals the last number. So once you have it in reduced row echelon form, this final column are your 3 answers. So, are you ready? Write small. Okay, so first up, we're going to take our system and we're going to write it as what it's called an augmented matrix, aka we're just using the coefficients. We're not going to use the x, y, and z. Remember, that's really a 1. So my first column, I have 1x. I like that. 2, 3. My second column, the coefficients on y are 3, 7, 10. My coefficients are z, 4, 5, 4. I like the dash line to separate to the equal sign. You don't have to put the dash line in. I just like it. 7, 10, 27. All right. So remember, 1 column at a time. I think I gave you all. Yeah, this one's got kind of a big number in it. You might want your calculator for this one. Okay, so first up. First thing I'm looking at. Like I said, we're going to work 1 column at a time. So I'm looking at the 1, 2, and 3. First thing I'm going to make sure that top left number is a 1. It is. If it wasn't, I might have a 1 underneath it and I could just flip-flop the rows. Let's say it was a, I don't know, a 4. I could divide everything by 4 also. A lot of times, especially since you're just starting, it will be a 1. It will be simple to get that. So my top row, I'm just going to fill in. I like it. We're going to roll with it. So the next 2 numbers I'm going to work on are the numbers underneath the 1, the 2 and the 3. Doesn't matter which one you do first. If you do the 2, then the 3, who cares? Doesn't matter. We got to do them both. So I'm going to work on the 2 next. So easy question. What would cancel out of 2? -2. So my row operation is this. I'm going to do -2 times the top row, and we're going to add it to this middle row. So I'm basically coming back to this guy, and I'm going to times everything by -2, and then I'm going to add them together. Now I'm pretty quick at mental math, okay? Some of you might, we're going to take a second and go slow here. -2 times 1, -2 plus 2. I need longer arms. -2 times 3, -6 plus 7. -2 times 4, -8. -8 plus 5. -2 times 7, -14. What's -14 plus 10? -4.
And the third row stays the same?
We're going to do third row here in a second one. Now, third row. Because we could, do it in a separate matrix, but I'm trying to do this with the least amount of writing. So I'm also going to deal with the 3, or work on the 3. So I'm going to erase this -2 up here for right now, so it's not in my way. Okay, easy question. What number cancels out of 3? So this time, I'm going to write my fancy row operation. I'm going to do the same thing, but I'm going to do the top row by -3 and add it to the bottom. So you're always working off that 1. You want to work off the row with the 1. So now I'm going to do this top one by -3, and then we'll add it to this guy. So here goes our mental math. -3 times 1, -3, plus 3. First column's perfect. -3 times 9, -9, plus 10. -3 times 4, -12, -12 plus 4. -3 times 7, at the corner there, -21, -21 plus 27, of course, 6. So I'm just going to take a second. Any questions on how I got any numbers in the second matrix? So fun, isn't it? It's so fun. Okay, I know. Okay. All right, let's carry it. And remember, I can usually do these unless something goes like way off the rails or something crazy happens. In general, it takes you 4 matrices to get to your final answer. So that's, I'm kind of spacing it. I've got half of it, so I'm thinking 3, 4. So that's kind of a guideline to judge your space. It usually takes you 4 matrices. So we work a column at a time. So the first column is picture perfect. We love it. I'm not going to change a thing. So now I'm looking at the second column, the 3, 1, 1. So the first thing I'm looking for in that second column is I want this guy to be a 1, which it is, because I want that diagonal ones. So I like it. My middle row is amazing. I'm just going to fill it in right now. So I'm going to fill in the 0, 1, the blue numbers. Keep it consistent. I'm going to write them in blue. Because what we're going to do, and it doesn't matter which one we do first, I'm probably going to do the top one. So we'd like our blue 1. I'm using that. We're going to change the 3, and then I'm going to change the 1. Doesn't matter which you do first. I don't know. I usually work top to the bottom, whatever. So easy question. What cancels out of 3? So I'm going to get fancy and write my row operations. So I'm going to do -3 times our middle row, and we're adding that to the top row. I'm kind of on the side there. Should have moved it over a little bit so I have more room to do work. So I'm going to do this guy by -3, then we're going to add it to the top. So -3 times 0, 0 plus 1. -3 times 1, -3 plus 3. There we go. That's what we wanted. -3 times -3, 9. 9 plus 4. -3 times -4, 12. What's 12 plus 7? 19. Fill that. Okay. We're cruising along. Now, what do you think in that red circled column is the next number I'm going to change? The 1, the black one at the bottom. Now, easy question. What cancels out a 1? So my fancy row operation, I'm going to do -1. Remember, we're working off the middle row. So now I'm just going to erase so it's not in my way here. Actually, I'm just going to cross it off because I'm afraid I'll erase too much. So now I'm going to do this guy by -1, and we'll add it to the bottom. So -1 times 0, 0 plus 0. -1 times 1, -1 plus 1. That's what we were after. -1 times -3, 3 plus -8. -1 times -4, 4, 4 plus 6. And I can tell you right now what z is. Any guesses? -2. Perfect. Because our bottom row, can you make this a 1 super easy? Because I could divide all of this by what? 5, negative 5. Now, am I going to rewrite the whole darn matrix just to make that a 1 and a negative 5? I can't really see as I have that on me on a rainy Monday morning. And I usually don't. So I just do a little cross off, or you can erase them. I'm going to make that a 1 and a negative 2. So we know, I'm just going to table it. We know z is negative 2. If you want to just straight erase them out and rewrite 1 and negative 2 in there, do it. I'm just going to leave them up there for dramatic purposes. All right, we are on the final and fourth matrix for this problem. Now remember, we work a column at a time. So you're on the third column, you've got the diagonal 1, we love the diagonal 1. My third row, that black row, is perfect. We don't want to change it because we know z is negative 2, so I'm going to fill it in. I'm not going to rewrite z as negative 2, we already know it. Okay, so we're working on this third column. Now, we need to change the negative 3 to a 0. You need to change the 13 to a 0. I don't care what you do first, we got to do them both. Who cares, okay? I'm going to do the negative 3 because it's smaller. It's my logic thinking here. So to get rid of negative 3, we need a 3. We're going to times it by that perfect third row, and we are adding it to the middle. So I'm going to do this guy by a 3, and we're going to add it into that one. So 3 times 0, 0, plus 0. Hang on, 1. 3 times 0, 0, plus 1. 3 times 1 is 3, plus negative 3. That's what we wanted. 3 times negative 2, negative 6. What's negative 6 plus negative 4? Negative 10. So you now know y is negative 10, which we'll write out in a minute. Okay, final row calculation. The 13 has to go. What cancels out of 13?
Negative.
So my fancy row operation. Well, remember, working off our perfect bottom row. So now I'm going to times this by negative 13, add it to the top. Negative 13 times 0, 0, plus 1. Negative 13 times 0, 0, plus 0. Shocker. Here we go. Negative 13 times 1, negative 13. That's that. Here's where it really counts. What is negative 13 times negative 2? 26. What's 26? You need a calculator probably. 26 plus 19. 45. So x is 45. Y is negative 10. Z is negative 2. And you can write it ordered pair style too. I don't really care. All right, Juan, what were you going to ask me?
Wait. The first thing you did was 3 times the bottom row.
Yep, to make this a 0.
Plus the middle row?
Mm-hmm.
Okay.
And again, this is, I feel like it's like when you do proofs in geometry. You're like, oh my God, this is awful. What are we doing with our lives? But it gets easier as you go. I promise. Yeah.
I just want to ask, so how do you know which rows to multiply and add to?
So you always, like I said, you want to work that column at a time, and you always want to work off the 1 in the column. So I'm always going to multiply wherever my 1 is and add it to the other rows. So you're always looking for the 1 and use that to change the other numbers.
So it doesn't matter with the second, like what you added to?
Mm-mm. All right, so ready for some more? I see you guys already filling in the first step here. Now, I got fancy on you, not really. That's kind of sarcasm. Notice your first equation, the top one, you're missing what letter? Y. So what is holding the place? 0. Make sure you have these in order, and if you're missing anything, okay. So of course, top left is a 1. Nice tea today, nice. So my first column, of course, 1, 3, 2 for x. 0, catch the 0. 1, 2, bless you. Okay, catch the negative on that 3. That negative sign goes to the 3. And a 1. I like the equal sign. That's my dashed line. And that is your augmented matrix. Are we ready? Love it. I feel the love today. Okay, so column at a time. As always, you usually will have a nice one to start with, so we're working on this column. So I love the 1. We're going to keep the 1, so I'm going to fill in the first row. And we're going to work on changing the 3 and the 2 underneath. Now, it doesn't matter if you do the 3 or the 2 first. They both have to be converted to 0. So I'm just going to do the 3 next. What cancels out a 3? So I'm going to use my 1, the top row. We're going to times it by -3, and then we're going to add it to the middle one. So my fancy row operation, if you want to write it out fancy, -3, top row, add to the middle. So I'm just going to go through and do all those calculations. 1 times -3, -3 plus 3. That's what we were after. -3 times 0, 0 plus 1. -3 times -3, 9. 9 plus -2. -3 times -2, 6. 6 plus 5. Got it. All right, next number, 2. What cancels a 2? So now I'm going to change it. I'm going to multiply this by -2 and add it to the bottom. So I'm going to write my fancy row operation. Times the top row, we're adding to the middle. I'm going to give, clearly I'm going to do it, but you should end up with 0, 2, 7, 8. This is what you should have had. So let's just do the math quick. -2 times 1, -2 plus 2. I saw everybody had that. -2 times 0, 0 plus 2. I think most of us had that. -2 times -3, 6 plus 1. And a couple of us had this one off, and I'm guessing maybe a sign. -2 times -2, 4 plus 4. So there's our 0, 2, 7, 8. Now remember, in general, it takes us 4 matrices. So I'm on the third one. Really, I kind of think of it as 3. The first one is just the original problem in a matrix style. Okay, column at a time. So I'm looking at this column now. Now, remember, you want diagonal ones. Ding, 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 ding. That blue one is a win. I like it. I don't need to change it. So first thing I'm going to do over there is just fill in the middle row of my blue numbers. We're going to, well, this is a win too. You got a 0. I don't have to do anything. Yes, I'm crushing it. So the only number that's a problem for me in that column is the 2. So let's fill in the top row. I'm going to leave it because you have that 0. I'm going to fill in the middle row, my blue numbers, the 0, 1, 7, 11. And the only thing we have to change out is the bottom 2. Now remember, you're working off where the 1 is. So I'm working off my blue numbers. Easy question. What cancels out of 2? So we're going to multiply this row by -2, and we're going to add it to the bottom one. So that's what we're going to do. I'm going to, well, I'll try to fit it in here. I'm going to write my fancy row operation. 2 times the middle row. So let's fill in our bottom row is perfect. We're on the final rounds of calculations. Now remember, you want to work off the 1. The 1 is amazing. We need to change the 7 and the -3. Doesn't matter which you do first. We're all going to get the same thing. I'm going to do the 7. So to get rid of 7, I know I need -7. So I'm going to times this guy by a -7 and add it to the middle. My fancy row operation, if we want to write that. -7 times row 3 into the middle. -7 times 0, 0 plus 0. -7 times 0, 0 plus 1. Here's where it counts. -7 times 1, -7 plus 7. That's what we needed. Okay, -7 times 2, -14. What's -14 plus 11?
3. -3.
So y equals, okay, I'll write that in a minute. Final calculation, the -3. What cancels -3? 3. So we're really going to do 3 times our bottom row and add it to the top. But really, I'm just going to cross off the -7 now and do a 3. So 3 through the bottom, add to the top. 3 times 0, 0 plus 1. 3 times 0, 0 plus 0. 3 times 1, 3 plus -3. Here's where it really counts. 3 times 2, 6. 6 plus -2. 6 minus 2. 4. X is 4. We already said y was negative 3. Z is 2. So fun, isn't it? It's a process. All right.
The bottom, you said -3, bottom row, and then add to the first one. So it wasn't -3.
For this one, I did 3 times the bottom row added to the top because I want to get rid of -3, so I needed a 3. So
Oh,
3.
So not -3, just
Correct, 3. Yeah. All right. Final one to torture you with today because we're doing more tomorrow. Okay. So X is nice. Y. Oh no, Y in the middle one. Catch the 0, of course. How we torture high school kids. Come on. Okay. Z's.
Gauss Jordan.
And then 3, 1, 0. So like I said, 4 matrices, but I don't even hardly count the first one because it's just writing out the original problem. Whatever. All right. Column 1. We'll work on that. You've got your top left one, which is perfect. So we can just go ahead and fill in our top row. And we need to change the numbers underneath, the 1 and the 2. Now, I do not care which we do first, because I feel like it. I'm going to do the 1. Easy question. What cancels a 1? -1. So we're going to times this whole row by -1, and I'm going to add it into the middle. And a lot of times, I'll be honest, I don't even necessarily always write out those fancy row operations. I just kind of do that. And you're welcome to do this too. Okay? -1 times 1, -1 plus 1. -1 times 1, -1 plus 0. -1 times -5, 5 plus -2. -1 times 3, -3 plus 1. All right, let's do the 2. So easy question for you, what eliminates a 2? -2. So we're going to do our, I just kind of cross them off. I'm going to do the top one by -2. We're going to add it into the bottom. I'm going to give you a second to do the math. See what your bottom row is going to be. Glance at -2 times 1, -2 plus 2. Everybody have that. -2 times 1, -2 plus -1. I was glad to see we had -3. That's an easy, thing to miss the negative. -2 times -5, 10. 10 minus 1. -2 times 3, -6 plus that. Okay, and then I said your bottom row, you can divide them. You should be able to reduce them. We can reduce them all by what? 3. You could do even -3. It really doesn't matter to me. Get wild with it. Let's see what we want to do here. So I would reduce them just because it's always easy to work on smaller numbers. So I'm going to reduce them down. Let's do them by -3. So I'm going to have 0, 1, -3, 2. I'm going to fill in my blue numbers. Now, I'm also going to work smarter, not harder here on my blue numbers. Because remember, you want diagonal 1s here. Well, I've got -1. I can make that a 1. How do I make it a 1? Just switch the, yeah, so I'm just going to switch them. I'm just going to switch them. So 0, 1, this is interesting. We have it screwed up, but what do you notice? So our red and blue are the same. So right now, I can give you half of the final answer. What do you think half of the final answer is? When you have the same equation, really. Infinitely many. So that's half of it. Now you're probably like, why can't I write IMS and be done? Well, we have to do that crazy Z is A shenanigans. And it's gonna, Johnny, it's gonna be easier, I promise you, once, excuse me, we get this in reduced row echelon form all the way. Once we have all our diagonal 1s and the 0s, I promise you it will be easier. So I am now working on my second column. The blue one is perfect. The diagonal one, I'm going to keep that one and see where we're at. So fill in the middle row. Your blue numbers are phenomenal. So we need to swap out the green one to a 0 and the red one. Does it matter what you do first? No, who cares? Okay, I'm going to do the top green one. I picked up green, that's why. So I want that to be a 0, so I'm going to have to times this guy by -1 and then add it into the top. So -1 times 0, 0, plus 1. -1 times 1, -1, plus 1, that's what we needed. -1 times -3, 3, plus -5. -1 times 2, -2, plus 3. Should close that up. Okay. All right, let's do the bottom one. Now, I still am multiplying by -1. I need a -1 to cancel it, but now we're just going to add it into the bottom row. -1 times 0, 0, plus 0. -1 times 1, -1, plus 1. -1 times -3 is 3, plus that. Shocking news here. -1 times 2, -2, plus 2. Now, shocking news, not real, that was my sarcasm, because what's this, all the zeros, the red zeros, what does it mean? If I said write that as an equation. 0 equals 0. 0x, 0y, 0z, which clearly is our IMS. But we spotted that, the IMS, earlier when we saw those same equations. Now, I'm just going to scroll it up a little bit so I'm not clear at the bottom for you guys, because we still have to do with our 3 equations, 3 variables, that crazy z is 8 thing. But I think it's easier in the matrix style. Because if I said, hey, write your blue equation as a matrix, 0x, and I just started with the blue. You can start with the green, who cares? I started with the blue. 0x, I'm not writing that, 1y minus 3z. Well, I can pretty much give you the expression for y in my head. Because if I put an a in here, whoops, so it's minus 3a, who cares? And I'm going to add that over. So I'm going to have 3a plus 2. And then I'm going to do the top equation. I'm going to rewrite that equation style, 1x. I'm not writing 0y. And you can probably throw an a in there for z and add that over in your head. What's x going to be? 2a plus 1. So that part is easier, if there's any silver lining. Is there no silver lining? No silver lining? Love it, love it. Now, I will tell you this, okay? Here's my spiel on this. Is it time consuming and a little painful? Yes, I'm not going to lie to you, it is. I will tell you though, these row operations come into play when you have to do inverse of a matrix in another section. So the better you are with this, the easier your life will be on this chapter. This also is the hardest part of the chapter, is doing this Gauss Jordan stuff. If you can do this, the rest of it's ridiculously easy, okay? I would never lie to you, right?